Okay, so let's start. So what we are required is to find the ratio of moment of inertia of this system. What is the system? Three masses on the vertices of an equilateral triangle. Okay, side length is given L. Okay, so first we will find moment of inertia about B, then about A. Now A is given. What is A? A is the centroid. Okay, so A is the centroid, and we know the coordinates of centroid from mathematics: x1 plus x2 plus x3 by 3, or whatever the coordinates, it's easy mathematically, you can find it. So A is the centroid. Now in this case, A is also the center of mass. Okay, for this whole system, A is the center of mass also, because if you find the coordinates of center of mass, it will coincide with A. So A is the centroid also, centroid for the triangle and center of mass for the whole system. Okay, so it is only because it is an equilateral triangle, so this is centroid, and because all the three masses are equal, so it is also center of mass. Okay, if suppose this M would have been 2M, then this will not be the center of mass. It will still be the centroid of the triangle, but not the center of mass, because center of mass not only depends on the shape or this coordinates, but also on the mass. So if the masses were different from this, then the center of mass would not be here. It will be like, suppose if this was 2M, if this was 2M, so the center of mass will shift a little bit upwards. Okay, but right now the centroid and center of mass are at the same position. Okay, so let's move forward. So what we will require is that we will need this length also, AB length, because we need to find moment of inertia about A, so we will require the length between this point and the masses. So all these length will be equal. So how are we going to find this length? Let's see here. So we draw the same triangle, and then we know that this centroid lies on the median. So this centroid is center of mass, same thing for this question. And this BM, this is the median. Okay, and because this is an equilateral triangle. Okay, so by symmetry this will be 90 degree. Okay, this angle will be 90 degree, so the right angle triangle will form here. Now this BM, this is the median, and the centroid divides this median in 2:1. So first we find BM length. This BM length is equals to L sine 60. L, this length is L, and L sine 60. So L root 3 by 2. This L root 3 by 2 is equals to, let's suppose 2:1. So this is 2x, this is x, and equal to this. From here we get x is equals to L upon 2 root 3. So this 2x length is equals to L by root 3. Okay, so now let's move forward and find moment of inertia about B. Now there will be many axes through B. About which axis we are going to find? So we are finding moment of inertia about B and axis through B perpendicular to the plane of this triangle. Okay, okay. Now moment of inertia for this mass 0, for this mass is ml square, for this mass also ml square. About B we are finding this length. Now similarly we have found the distance of these masses from A also, which is L by root 3. But what if we want to use some other method? So we let's use parallel axis theorem. Now you know what is parallel axis theorem, that if you know moment of inertia about center of mass, so if you know about this and you want to find about any other point, you just have to multiply the mass of the system and distance between the 2 points, that is the center of mass and that point about which you want to find the moment of inertia. So we want to find about B. So how will we find? The ICOM plus MD square. Okay, so ICOM plus, now mass of the system is 3m, m, and m, 3m. And what is the distance between these 2 points? L by root 3. So this L by root 3, and we will square it. So L square by 3 is equals to, we already found about IB, which comes out to be 2 ml square. Okay. So from here we get the center of mass, moment of inertia about center of mass ml square, and from here we can find the ratio, that is 2:1. Okay, so now some points that I've already mentioned, that we use this parallel axis theorem. Okay, we could have simply found using this also about A, but why I did this, because I wanted to tell you that we were able to use this parallel axis theorem, but parallel axis theorem requires what? Center of mass. So in this case we found this distance, assuming that this is also the centroid of the triangle. Okay, this is also the centroid of the triangle, because only the centroid lies on the median. Okay, also in this case, as I told you earlier, the centroid and center of mass were at the same position because of the symmetry of masses, and this is equilateral triangle. So these are some things which you have to remember. Now if this mass would have been 2m, the center of mass would shift somewhere here. Now centroid is still here, this is still the centroid, but this is now not the center of mass. So now you can't use this parallel axis theorem like this. Okay, because now you can use parallel axis theorem, but then this will be the distance, d value will be this one, so you have to calculate this. Now this will be different for all, these two will be equal, but this will be different. Okay, so why we were able to use this parallel axis theorem? Because here center of mass and centroid were coinciding.